Hello. In last video we have studied problems on projections of lines inclined to only one reference plane. In this video we'll study how we can solve problems on projections of lines which are inclined to both the reference planes. Both the reference planes I mean HP and VP. Projections of lines inclined to both the reference planes, the HP and the VP. What we studied in the last video is, if line is parallel to VP, then its front view gives true length, front view gives true inclination with, of course, HP, because front view gives detail with respect to HP. So front view gives true inclination with HP and top view appears parallel to XY line. And if line is parallel to HP, then top view gives true length and true inclination with VP. Top view gives true inclination with VP. And front view appears parallel to XY line. So this is what we studied in the last video, but I'll recommend you to remember few statements. These statements, if you remember, you will able to solve lines problems very quickly, very mechanically. Which are those statements? Check. Front view gives true length and top view parallel to XY line. Remember, front view showing true length is always associated with parallel top view, and top view with true length is always associated with parallel front view. Parallel in the sense parallel to XY line. So remember this statement: front view parallel, top view true length, and top view parallel, front view true length. Front view gives true length and true inclination with HP. This is very important to remember that only true length view gives true inclination. Check here, top view gives true length and true inclination. Only true length gives true inclination. Also remember here, theta is standard notation for true inclination of line with HP, and phi is standard notation for true inclination of line with VP. Also, top view is parallel to XY line. And what is length of top view? Not true length. If line is parallel to VP, not parallel to HP, means inclined to HP, then front view gives true length, but top view does not give true length. So length of top view is denoted as PL. P means plan length means top view length. Similarly, when line is not parallel to VP, then its front view does not give true length. What is length of front view? EL. EL means elevation length. This is how we denote front view length. So remember these standard notations. So if line is parallel to VP, then and only then it gives true length and true inclination in front view. And if line is parallel to HP, then and only then it gives its true length and true inclination in the top view. So what if line is not parallel to any one of the two reference planes? Then in both the views it does not give true length. And since we know that only true length gives true inclination, we are also sure that if line is inclined to both the reference planes, then in both the views it does not give true inclination also. So if line is inclined to both HP and VP, then in front view as well as in top view it do not show true length and true inclination. So here is an example. Line AB 100 mm long is inclined to HP by 45 degrees and to VP by 30 degrees. So line is inclined to both the HP and also the VP. So let's write data properly. True length is 100 mm. True length of the line is 100 mm. Its inclination with HP is 45 degrees. We use standard notation theta for inclination with HP. So theta is 45 degrees. And it is inclined to VP by 30 degrees. We use standard notation phi for inclination of line with VP. End A is 15 mm above HP and 20 mm in front of VP. There are infinite points on the line. But there is one point on the line, that is end A, whose position from HP as well as VP we know. The point whose position from both the reference planes is given or known. Such a point is reference point, also called as fixed point. So end A is 15 mm above HP and 20 mm in front of you. Let's note down this here. This is how we note it. This line consider as XY line. Here it is projector of point A, 15 millimeter above HP. So we should measure 15 millimeter above XY line, and that is front view of point A, and 20 millimeters in front of VP. So we should measure 20 millimeters in front of XY line, and top view gives distance from VP. Each and every statement gives you certain information, and you should first bring it on paper properly as data. End B is in first quadrant. What do you mean by that? Front view above XY line and top view below XY line. That means B dash is above XY line and B is below XY line. So we'll note down here as data. So this is what the information we have in this problem. Line is inclined to both the reference planes. So line is inclined to both the reference planes. That means in both the views it is not showing its true length as well as its true inclination. Then what logic we use to draw projections of lines inclined to both the reference planes? That is we are going to study in this video. So set roller with horizontal edge of drawing paper, roll it and draw horizontal line. This is XY line. Then draw projector of the reference point. What do you mean by reference point? Point on the line whose position from both HP and VP known. So here it is point A whose position from HP VP known. So let's mark it properly now. So measure exact 15 millimeters above XY line because point A is above HP, and front view gives distance from HP. So label it immediately, and 20 millimeters below HP. Prompt labeling is very important in solving problems on projections of lines. So now set roller with XY line, and through A dash draw a horizontal line, and through A draw one more horizontal line. Now front view is A dash B dash, and B dash is above XY line, not below XY line. So A dash B dash will be oriented in this manner. But is front view showing true length 100 millimeter? No. That means A dash B dash is not showing true length, and therefore it is also not showing true angle. A dash B dash does not have 100 millimeter length, or A dash B dash is not at an angle 45 degrees. Then how to draw A dash B dash? And in the same way, AB is top view. Line is not parallel to HP, then of course top view is not showing true length. So top view does not have length 100 millimeter, we are sure about that, and top view also is not inclined at 30 degrees, we are sure about that. Then how to draw that top view AB? And exactly that is what we are going to study here. So let's assume line parallel to VP. Means we'll assume this angle phi equal to 30 degrees as 0. So this is our assumption 1. What we'll achieve by assuming line parallel to VP? That we'll discuss later. But now it is very easy to draw views of the line, because we know that if line is parallel to VP, then front view gives true length. Front view gives true inclination with HP, and top view appears parallel to XY line. So let's draw now front view. Simple. Now we are drawing front view. Front view is A dash B dash. So you should draw it at point A dash. Measure angle 45 degrees. And then draw a 100 millimeter long line. That is true length. So front view is showing true length and true inclination. Label the point immediately as B dash. So front view is showing true length and true inclination with HP. But we also know that if front view is true length, then top view is parallel to XY line. Also we know that two views of a point lie on same projector. So here it is front view of point B. So you should draw projector from B dash. So on this line somewhere point B is. Is it point B? Of course not, because we know that top view is parallel to XY line. And if front view is A dash B dash, then top view is AB. So B must be here. And this is top view. What is length of top view? PL. So we have completed views of line which is parallel to VP. But this is not the final drawing. These are the views of the line in certain assumption. And what is our assumption? Line is parallel to VP. Now we'll assume line parallel to HP. That is, inclination of line with HP theta is equal to 0. So this is our second assumption. Line is parallel to HP and theta equal to 0. In this case, we know that if line is parallel to HP, then top view gives true length and true inclination, and front view appears parallel to XY line. So let's proceed. Here is XY line, the projector of reference point E, this line. Now here we are drawn. Then we'll look at A dash and A. So these are projections of reference point. Draw horizontal lines through A dash and A. So same thing what we did here in the first stage. So in this case, what we know is top view is true length, top view gives true inclination with VP, and front view is parallel to XY line. What is true inclination with VP? 30 degrees. So let's measure 30 degrees at point A. And no confusion at all. We are drawing top view which has true length and true angle. So top view is AB. So we should measure that angle at point A. So I have measured angle 30 degrees at point A. And this is that true length 100 millimeters. And true inclination with VP. So top view gives true length and true inclination with VP. Let's label this point as point B because it is top view. No dash you should use here. Now one very important thing is, it's clearly mentioned in the problem that top view of point B is below XY line. In the sense, B is in first quadrant. So front view above, top view below. So top view of point B is below XY line. That is why we have measured 30 degrees downwards. If we would have measured 30 degrees upwards, then we would have got point B above XY line. And that would have been mistake. Okay. So now B. Draw vertical line through B, that is projector through point B, and on this projector B dash is, and we know that front view is parallel to XY line, means A dash B dash somewhere on this line B dash is, A dash B dash is parallel to XY line. So through B draw projector and mark B dash. B and B dash must be on a vertical line, that is on a single projector. So A dash B dash is a front view, and its length is less than true length. So we should label it as EL. EL means elevation length. E for elevation. And what do you mean by elevation? Front view. Now, we have drawn views of the line under certain assumptions. So we are going to make certain corrections in labels. In the sense, here it is a B dash. But this is not correct position of B dash. The reason is we have drawn views of the line under certain assumption. So we say that this point is B1 dash. This is how we label, and therefore this point is B1. Why suffix 1? Because these are the views of lines under first assumption. Then why should not we label this point as A1 dash? The reason is point A is a reference point and it is fixed point. Whatever may be our assumption, we have not changed the position of point A. Check here, point A is 15 mm above HP, 20 mm in front of VP, and here also point A is 15 mm above HP, 20 mm in front of VP. But point B's position has changed. So we say that this is position of point B in first assumption, and here it is position of point B in second assumption. So we'll label it as B2. Since it is top view, we should not use dash here, and therefore this point is B2 dash. Now we are ready to draw views of the line in given position. But to draw those views of line in given position, you must know what really we have achieved by assuming line parallel to VP first and then by assuming line parallel to HP. Let's see. By assuming line parallel to VP, what we have achieved, try to understand. Watch geometry of this diagram. TL, that is true length of the line, and that makes angle 45 degrees with XY line. So this horizontal edge of this right angle triangle is TL cos theta, and that is PL. So here you must notice that plan length of the line purely depends on inclination with HP. PL has nothing to do with inclination with VP. If you change this angle theta, TL cos theta, that means this length PL will go on changing. So by assuming line parallel to VP, we have found out plan length of the line, PL. And what else we have found out? Listen, B1 dash, this vertical edge of this triangle. What is length of this vertical edge? True length sin 45 is that, plus 15, true length sin 45 plus 15. What is that? Distance of B1 dash from XY line. So here this is a distance of point B from HP. What you should understand here is, if you change this angle theta, if you reduce that angle theta, B1 dash moves closer to XY line. What does that mean? Distance of point B from HP purely depends on inclination with HP. It has nothing to do with inclination with VP. So when line is inclined to HP by 45 degrees, distance of point B from HP we have found out. What does that mean? B dash is also at the same level. B dash, front view gives distance from HP. So B dash is also at the same level. So by assuming line parallel to VP, we have found out top view length of the line and distance of point B from HP. Similarly, assuming line parallel to HP, what we have achieved? Front view length of the line and also distance of point B from VP. Which view gives the distance from VP? Top view. So distance of point B from VP depends on this angle. If you reduce this angle, then point B will move closer and closer to XY line. So distance of point B from VP depends on inclination with VP. We have assumed line parallel to HP and we have found out front view length of the line and distance of B from VP. Therefore, I have drawn a horizontal line through B1 dash. What this horizontal line means, listen, distance of B from HP in the first assumed position gives you distance of point B in correct position also, that is in the given position. So B dash is also on this level. Also we have found out distance of point B from VP. B2 gives distance of point B from VP. What does that mean? B is on this line. So B is at this level. So we are ready to complete views of this line in given position. So draw XY line as usual. Draw projector of the reference point, that is A dash and E. Draw horizontal lines. Here it is A dash and here B dash. B dash gives distance from HP, and as I told you, in first stage we have found out distance of point B from HP, and this is the distance of point B from HP, and that is why we say that B dash is on this line, because B dash gives distance of point B from HP. So here it is B dash, and also length A dash B dash we know. What do you mean by A dash B dash? Front view of the line, and length of the front view is here. EL means length of front view. Take this distance in compass. EL means elevation length, means front view length, and from A dash is here and B dash is on this line. So cut this line. So this is how we have found out front view of the line. What is length of this line? EL. Label this point immediately as B dash. So this is how we have drawn A dash B dash. Similarly, we are ready to draw top view also. Top view is AB. Length of the top view is PL. So take this length in compass, that is PL or top view length, and from point A you cut this line. So this is how we have found out point B. Join AB, and that is top view. And what is length of top view? PL. This is that PL we have achieved in first stage, and this is that EL we have achieved in second stage. Now, as I told you, that is two views of a point lie on same projector. So if you draw projector from point B dash, it must pass through B, because B dash and B must be on the same projector. And if not, if B and B dash do not lie on the single vertical line, that means you have made mistake somewhere here. So let's check it. So B dash, I have drawn vertical line and our construction is perfect. B dash and B are on the same projector. Now watch carefully. This angle of EL is not 45 degrees. Compare it with this angle. This angle is greater than 45 degrees. And what it is, right now we need not know. We have completed the views of the line. But you should know notation used for inclination of front view. Inclination of front view of the line is alpha. Similarly, this angle, if you compare it with this angle is greater than 30 degrees. So we use notation beta for that angle. So actual views of the line in given position, this is front view and this is top view. Have you noticed? Front view is not showing true length and true angle. This angle is not 45 degrees. This length is not true length. Similarly, top view is not showing true length and true angle. This angle is not, this length is not true length, and this angle is not true inclination. EL and PL are called apparent lengths. Apparent means that is what appears and not true. Alpha and beta are called as apparent angles. Line appears to be inclined to HP by angle alpha, but no, actual inclination is theta. So theta is true inclination and this is apparent inclination with HP. So now remember, true length gives true inclination, true length gives true inclination, but inclination of front view is alpha and inclination of top view is beta. Remember this. There are three pairs of views, front view and top view, a pair of view. So front view and top view in first assumed position, front view and top view in second assumed position, and front view and top view in given position. These three pairs of views we superimpose. So here the views are superimposed. But remember, we should draw only the front view and the top view in given position dark. All other front views and top views must be faint, thin. So this is how the drawing will appear on paper. Check here, only two lines are dark. A dash B dash, that is front view, and AB, that is top view. Now we'll observe this drawing very carefully. And our observations will write as points to remember. And of course, you should take efforts to remember these points. If you remember these points, then you will be able to solve lines problems very quickly and very easily. So what are our observations? Check. There are three front views and three top views. A dash B dash, A dash B1 dash and A dash B2 dash. Three front views. AB1, AB2 and AB. Three top views. So first thing you will have to remember, that is AB, AB1 and AB2. Three top views, and A dash B dash, A dash B1 dash and A dash B2 dash. There are three front views. So how we label these six views, you will have to remember, because it is standardized labeling. But not only that, corresponding length and inclination, that is angle with XY line, you will have to remember, of course, in terms of notations. So what is length of AB? PL, and inclination beta. Now check AB1. AB1 has length PL and angle 0, in the sense it is parallel to XY line. So AB1 is always has length PL and it is parallel to XY line. And then AB2, check here AB2. AB2 is true length. And of course true length gives true inclination. But it is top view. And top view gives inclination with VP. So this 30 degrees in this problem is inclination with VP, that is phi. So true length gives true inclination. AB2 has true length and its true inclination. A dash B dash. A dash B dash has length EL and inclination alpha. Check. Alpha is angle made by front view with XY line. A dash B1 dash. A dash B1 dash has true length and inclination, true inclination. In this problem, the true inclination theta with HP is 45 degrees. And A dash B2 dash has length EL and it is parallel to XY line. 3 top views, 3 front views. Now check here. All the 3 front views, A dash B dash, A dash B1 dash and A dash B2 dash are passing through front view of the reference point. Similarly, 3 top views, A B1, A B2 and AB. All the 3 top views are passing through top view of the fixed point. So we'll mention here, all 3 top views pass through top view of the fixed point. All 3 front views pass through front view of fixed point. What else our observation? Check here, B dash and B1 dash. Always remember, B dash and B1 dash lie on a horizontal line. B and B2 lie on a horizontal line. So B dash and B1 dash on a horizontal line. B and B2 on a horizontal line. Also remember, reference point will not have any suffix. Because in all these 3 positions, which are the 3 positions? First assumed position, second assumed position, and in given position. In all these 3 positions, point A remains in the same position. That is why this reference point is also called fixed point. And therefore, there will be no suffix 1 or 2 for reference point. If point A is a fixed point, there will be no point A1 dash or A2 dash or A1 or A2 in the diagram. Remember this. Here it is line AB. But what if it is line PQ? No problem at all. We'll label in this manner. Only letters are changed. That's all. PQ, PQ1, PQ2. 3 top views. P dash Q dash, P dash Q1 dash and P dash Q2 dash. 3 front views. Assuming point P as a reference point. What if point Q is reference point? No problem. QP, QP1 and QP2. And 3 front views are Q dash P1 dash, Q dash P2 dash and Q dash P dash. Simple. So if labels given to the ends of given line are different, say RS, then you should not get confused at all. If letters are changed, that doesn't mean that it's different type of labeling. If it is line RS and point R is fixed, then RS, RS1, RS2. 3 top views. All 3 top views pass through point R, top view of the reference point. And R dash S dash, R dash S1 dash and R dash S2 dash. These 3 front views. Also, S dash and S1 dash on the same level, that is on the same horizontal line. S and S2 on the same horizontal line. Remember, this is what you are going to observe in all the problems and that is why you remember it. Watch this drawing again. And you will find that from each labeled point, there is a horizontal line and a vertical line. Check, through A dash, there is vertical line, there is horizontal line. Through A, there is vertical line and there is horizontal line. Through B, there is horizontal line, vertical line. Through B1, there is horizontal line, vertical line. So you will find that through each labeled point, there is a horizontal line and a vertical line. So you are always going to draw horizontal, vertical lines through all labeled points. Do you remember, if you mark A dash, through A dash, do you draw horizontal line? When you mark A, through A, you draw horizontal line. Horizontal and vertical lines through all labeled points are required. Not only that, through a labeled point, when you draw a horizontal line, which is the other point on that line will be known to you. In each and every horizontal and vertical line in your drawing, on projections of lines, you will find that there are two significant points. Check here. A dash and A on this vertical line, check here. On this vertical line, B dash and B. On this vertical line, B1 and B1 dash. Here on this vertical line, B2 dash and B2. You will find that 2 points on each vertical and horizontal line. Check here. On this horizontal line, B and B2. That is what we have already mentioned here. B and B2 lie on a horizontal line. Check here. A and B1 lie on a horizontal line. B dash and B1 dash lie on a horizontal line. Check. We have already mentioned here. B dash and B1 dash on a horizontal line. A and B1 on a horizontal line. Where we have mentioned here, check here. A B1 is parallel to XY line. A B1 is parallel to XY line. Similarly, A dash B2 dash is parallel to XY line. Means A dash B2 dash on a horizontal line. Through a labeled point, when you draw horizontal line, you will be always knowing which is the other point on that line. That is through B dash. When you draw horizontal line, you are sure that on that line B1 dash is. Because B dash and B1 dash lie on a horizontal line. Through point B, when you draw horizontal line, you will be always knowing which is the other point on that horizontal line. So when you draw horizontal line through B, which is the other point on that line? B2, because B and B2 lie on a horizontal line. This is true in all problems, and that is why you should remember these points as rules. Tell me, through A, when you draw horizontal line, which other point on this line? B1. AB1 is always horizontal view. AB1 is always parallel to XY line. Check here. Here it is A. Through A, if you draw horizontal line, on that line there should be B1. Because it is mentioned here, AB1 is parallel to XY line. Okay, so this all information, how we use to solve problems, we'll try to understand using the same example. So read the problem. Line AB 100 mm long. So true length is 100 mm. It is inclined to HP. Line is inclined to HP. Means it is true inclination with HP. We use notation theta for true inclination with HP. And it is inclined to VP. The line is inclined to VP by 30 degrees. True inclination with VP, that is phi. It is 30 degrees. Its end A is 15 mm above HP and 20 mm in front of VP. Let's note this data also. This is XY line, imagine. So, on the projector of point A, we are going to mark front view 15 mm above XY line. Because point A is 15 mm above HP. Above HP means on drawing paper above XY line. And this is distance from HP. Front view gives distance from HP. So label it as A dash. And 20 mm in front of VP. In front of XY line measure 20 mm and top view gives a distance from VP. Draw projections of the line if its end B is in first quadrant. End B is in first quadrant. First quadrant means front view of point B above XY line and top view below XY line. First quadrant means front view above. So this is the information in the problem. Now start drawing in the sense. Set roller with XY line. And very first line you will draw, that is XY line. Label it immediately. Labeling is very important. Leave some space from left end of XY line and draw projector of the reference point. What is the reference point? The point on line whose position from both HP and VP given. In this problem it is end A. So mark front view and top view of end A. Projector must be exactly perpendicular to XY line. So here is projector of point A, 15 mm above HP, A dash, and 20 mm in front of VP, that is A. Now as I told you, there must be horizontal lines, vertical lines through all labeled points. So here also we'll draw horizontal lines. But when you draw horizontal line through a labeled point, you will be always knowing which is the other point on that line. So horizontal line through A dash and horizontal line through A. What I said, that you will be always knowing which is the other point on that line. So tell me, horizontal line through A, which is the other point on this line? So AB1 is always horizontal. So on this line, point B1 is. I have made a circle here in the sense I don't know exact position of B1, but I am sure that B1 is on this line. Horizontal line through A dash. Which other point on this line? B2 dash. Remember, A dash B2 dash is always horizontal and A B1 is always horizontal. Through A dash, there are three front views. Out of those three front views, which three front views? A dash B dash, A dash B1 dash and A dash B2 dash. Out of the three front views, we can draw true length front view. True length is 100 and true length gives true inclination and front view gives inclination with HP. So we'll draw true length front view at point A dash. And true length front view shows true inclination 45 degrees. It is front view, so you should measure inclination with HP 45 degrees. And then you draw that true length front view. What is this length you have measured? 100 millimeter. So you should label this point as not B dash. A dash B dash, wrong. A dash B dash has length EL. This is not A dash B dash. It is A dash B1 dash. So label it properly, A dash B1 dash. Similarly, through point A there are three top views. Which three top views? AB. What is length of top view AB? PL and inclination beta. Now we don't know PL, we don't know beta, so we cannot draw AB right now. Then top view AB1. AB1 is parallel top view, it has length PL, but in this problem PL is not given. So we cannot draw right now PL. And AB2 is true length top view. True length top view. Top view gives inclination with VP. And what is true inclination of line with VP? Phi. It's given in this problem. So in this problem we know true length and we know phi, and therefore we can draw AB2. Remember, front view with suffix 1 is true length front view and top view with suffix 2 is true length top view. So we are drawing here AB2. So at point A, AB2 means of course you are going to draw through point A. All three top views through point A, top view of reference point. So measure that angle 30 degrees and draw true length 100 millimeters. And what is inclination? 30 degrees. Label this point as B2. Now this is very important to understand. You have brought all these measurements in your drawing. Have you used true length 100 millimeter? Yes, here we have measured 100 millimeters. Here also we have measured 100 millimeters. So we have brought all measurements on paper. So what is the procedure? Try to understand. Draw XY line, mark reference point, draw horizontal lines through front view and top view of reference point. Now through front view of reference point, three front views. Out of these three front views, which front view you can draw? That you check from data and draw that front view. Here we could draw A dash B1 dash because we know true length and theta. Also out of three top views, we could draw A B2 because true length and phi also given in this problem. So this is how, using 6 views logic, bring all measurements on paper, and out of 6 views, the views which you will able to draw, you should draw it. So in this problem, we could draw A dash B1 dash and A B2. After this, through label point, draw horizontal vertical lines. And don't forget, when you draw horizontal vertical lines through labeled point, you will be always knowing which is the other point on that line. So let's proceed. So through B1 dash, I am drawing horizontal line. Which other point on this line? So you know that B dash and B1 dash lie on the same horizontal line. So on this line, B dash is. Similarly, draw horizontal line through B2. B2 and B lie on same horizontal line. Therefore, we are sure that on this horizontal line point B is, and on this horizontal line B dash is. So B dash and B1 dash on a horizontal line, B and B2 on a horizontal line. Also, we should draw vertical lines through labeled points. Through A dash, A vertical line is already there. Now through B1 dash vertical line. But which other point on this vertical line? Of course, two views of a point lie on the same projector. So if it is B1 dash, Then on this vertical line there will be B1, top view of the same point. Okay, so through B1 dash I am going to draw vertical line. So let's draw vertical line through B1 dash. But when you draw vertical line through B1 dash, you must know that on that vertical line it will be point B1. Of course, two views of a point lie on the same projector. So B1 dash, so on the same line you will get top view of that point, that is B1. So draw vertical line through B1 dash and here you will get B1. Now correct position of B1 is known. So remove this rough label. Similarly, draw vertical line through B2 and here you will get B2 dash because we already know a horizontal line on which B2 dash. So draw this vertical line up to this horizontal line to locate B2 dash. Once you get that B2 dash, that rough label you erase. So this is how horizontal front view A dash B2 dash is there in our diagram and horizontal top view A B1 is also in our diagram. Length of horizontal top view, that is A B1, is PL and length of A dash B2 dash is EL. And now there are horizontal vertical lines through all labeled points. When you are sure there are horizontal vertical lines through all labeled points, then use compass and rotate either EL or PL. So here I am going to rotate EL. Watch here. So reference point is a center of rotation. Use compass. Take point A dash as center of rotation and radius as EL and rotate EL. Why rotate? So remember there is one more view that has length EL and which is that front view. EL is length of front view A dash B dash. A dash B dash has length EL. So rotate A dash B2 dash. Watch in the diagram. A dash B2 dash has length EL and which other view has same length EL? A dash B dash. And B dash is on this line. We are already labeled here that on this line point B dash is. And that is why we are not confused whether we should rotate in anti-clockwise direction or clockwise direction. So rotate A dash B2 dash to get A dash B dash. So here it is B dash. So we got the correct position of B dash. So remove that extra label. And through B dash draw vertical line. Why? Through all labeled points you should draw horizontal vertical line. So after using this compass you got one extra point. And what is that? B dash. So once you get B dash, draw vertical line through B dash. And you know which is the other point on that line. Two views of a point lie on same vertical line. So when you draw vertical line through B dash, on the same line point B is. So through B dash vertical line, on this vertical line point B is, top view of point B. This is front view of point B. So on this line, top view of point B. Now when you draw this vertical line, it intersects many lines. But not all these points of intersection are significant. We know where exactly point B is on this line. So extend that line, that projector up to this horizontal line and here you will get B. Check here B and B2 on a horizontal line. Now join A dash B dash and AB with dark line or thick line. So A dash B dash and AB. Is this drawing complete? Yes. How will you come to know that your drawing is complete? So check, in your drawing there must be 3 front views, 3 top views. B and B2 must be on a horizontal line, B dash and B1 dash must be on a horizontal line. Also only those two lines AB and A dash B dash thick or dark. Let's check our drawing. Check here. There are 3 front views, A dash B dash, A dash B1 dash, A dash B2 dash. There are 3 top views, A B1, A B2 and AB. B dash and B are on a vertical line. B1 dash and B1 are on a vertical line. B2 and B2 dash on a single vertical line. A dash and A on a vertical line. So this drawing is complete. Now insert dimensions. Always insert dimensions after completing the drawing. And those dimensions which you have used in the construction, means dimensions which are given in the question, those dimensions you should insert in the diagram. So here Watch here, the angle 45 degrees theta we have inserted, phi 30 degrees we have inserted here, distance of A dash and A we have inserted here, and true length we prefer to write outside the diagram, but in the diagram label TL. It is not necessary to label PL or EL, not necessary I said. If you label it, no problem, but it's not necessary. But you label true length and write outside the numerical value of true length. So this is how we should insert the dimensions. Now we'll summarize all those points to remember. And of course these points are very important. If you don't remember these points, you will not able to solve problems. Clear statement. You will not able to solve problems on projections of lines if you don't remember these points. So TL is true length. Theta is true inclination of line with HP. Phi is true inclination of line with VP. EL is elevation length, means front view length. Elevation is alternative term for front view. So EL is front view length. Alpha is inclination of front view with XY line or with HP, that is one and the same. So alpha is a notation used for angle made by front view with XY line. PL, that is plan length. Plan is alternative term for top view. So plan length or PL means top view length. Beta is angle made by top view with XY line. Inclination of top view with XY line or with VP, that is one and the same. And DBEP, that is distance between end projector, that is projector of end A and projector of end B, distance between these two vertical lines, that is DBEP. You will understand it in detail when we solve problems. Now with these notations also you should remember how we label the 6 views and length and inclination of each of those 6 views. So lines inclined to both the reference planes, there are 6 views involved, 3 front views and 3 top views, or you can say 3 pairs of views. 3 top views AB, AB1 and AB2. All these 3 top views pass through top view of point A. And 3 front views A dash B dash, A dash B1 dash and A dash B2 dash. All 3 front views pass through front view of point A. Now what about the length and inclination? So AB is top view. So top view has a length PL and inclination beta. Top view, AB is top view, length PL and inclination beta. AB1 is horizontal top view, that has length PL and it is parallel to XY line. AB2 is true length top view. It has true length and true inclination with VP because it is top view. Top view gives details with VP. A dash B dash has length EL and angle alpha. A dash B1 dash has true length and angle theta. And A dash B2 dash is horizontal EL, that is EL parallel to XY line. So it's very important to remember this. So this is called 6 views logic. While solving problems on lines inclined to both the reference planes, we are going to use the 6 views logic always. Also remember that B dash and B1 dash lie on a horizontal line. B and B2 lie on a horizontal line. If you remember all these points, you will not face difficulties in solving problems on lines inclined to both the reference planes. Only thing is, now we should have some practice of solving problems on lines inclined to both the reference planes. So remember all these points. In our next video, we'll start solving problems on lines inclined to both the reference planes. Till then, bye bye. Thank you.